Nanoparticles sound like something futuristic, but they are simply extremely small pieces of materials. The important part is not just that they are small, but that being small completely changes how they behave. This is where most students mess up. In chemistry, smaller often means more reactive and more useful. To understand nanoparticles properly, you first need to understand how scientists classify particle sizes. Very small particles are measured in units called nanometers. 1 nanometer is unbelievably tiny. It is 1/1000th of a meter. That is so small that even a single human hair is tens of thousands of nanometers wide. Particles are grouped into 3 main categories based on their size. Coarse particles are the largest in this context. They are still small, but compared to nanoparticles, they are huge. These include things like dust in the air.
Fine particles are smaller than coarse particles and can stay suspended in the air more easily. These are often linked to air pollution and can enter the lungs. Then we reach nanoparticles, which are the smallest of all. Their size ranges from about 1 nanometer to 100 nanometers. This means nanoparticles are made up of only a few hundred atoms. That is incredibly small compared to normal materials, which contain billions of atoms. This difference in size is exactly why their properties change. Question: what are nanoparticles? Nanoparticles are extremely small particles with sizes between about 1 and 100 nanometers. Question: how do nanoparticles compare in size to atoms? Nanoparticles are larger than atoms, but still very small, usually made of a few hundred atoms. Now comes the idea that actually matters and shows up everywhere in exams. Surface area to volume ratio. This is where students either understand everything or completely lose the plot. Surface area means how much of the particle is exposed on the outside. Volume means how much space the particle takes up. The ratio between them tells you how much surface is available compared to the size of the particle. When a particle gets smaller, something strange happens. Its volume decreases faster than its surface area. That means the surface area compared to volume becomes much larger. In simple terms, more of the atoms are on the outside instead of hidden inside. Imagine breaking a large cube into many tiny cubes. The total volume stays the same, but the total surface area increases massively. This is exactly what happens when materials are broken down into nanoparticles. Question:
what is surface area to volume ratio? It is the surface area divided by the volume of a particle. Question: what happens to surface area to volume ratio when particle size decreases? It increases, meaning there is more surface area compared to volume. Question: why is this important? Because more atoms are exposed at the surface and can react with other substances. This leads directly to why nanoparticles behave differently from bulk materials. In a large piece of material, most atoms are inside and not involved in reactions. In nanoparticles, a large proportion of atoms are on the surface, making them much more reactive. This is why nanoparticles are often used as catalysts. A catalyst is a substance that speeds up a reaction without being used up. Because nanoparticles have such a high surface area, they provide more space for reactions to happen. This means you can use a much smaller amount of material and still get a strong effect. Question: why are nanoparticles good catalysts? Because their high surface area means more atoms are available to react, increasing the rate of reaction. Nanoscience is the field of science that studies nanoparticles and their behavior. Scientists are interested in them because they can do things that normal materials cannot. For example, in medicine, nanoparticles can be used to deliver drugs directly to specific cells. This is powerful because it means treatment can be more targeted and effective. In electronics, some nanoparticles can conduct electricity and are used to create very small and efficient devices. In cosmetics and skincare, nanoparticles are used to improve how products spread on the skin and how ingredients are absorbed. In sun creams, nanoparticles are used because they provide better protection against harmful radiation while remaining transparent on the skin. Traditional sun creams can look thick and white, but nanoparticles solve that problem. Question: give one use of nanoparticles in medicine. They can be used to deliver drugs directly to specific cells in the body. Question: why are nanoparticles useful in sun cream? Because they provide better protection and spread evenly without leaving a visible layer. Some nanoparticles, like silver nanoparticles, have antibacterial properties. This is why they are used in deodorants and fabrics to prevent the growth of bacteria. Question: why are silver nanoparticles used in deodorants? Because they can kill or prevent the growth of bacteria. Now, before you start thinking nanoparticles are some perfect miracle solution, here comes the uncomfortable part. There are risks. Because nanoparticles are so small, they can enter the body more easily than larger particles. Scientists are still studying what happens when they get inside cells. The long-term effects are not fully understood, which makes some people concerned. There are also environmental risks. Nanoparticles can enter water systems through waste and may not break down easily. Some studies suggest that certain nanoparticles can be harmful to aquatic life. Question: why are some people concerned about nanoparticles? Because their effects on human health and the environment are not fully understood. Question: give one environmental concern about nanoparticles. They can enter water systems and may harm aquatic organisms. Here is the part where you need to think like someone who actually understands science instead of just memorizing facts. Every new technology has benefits and risks. The smart approach is not to blindly accept or reject it, but to evaluate both sides. Nanoparticles can make medicine more effective, reduce the amount of expensive materials needed, and improve products we use every day. At the same time, their long-term effects are still being studied, and careless use could lead to problems. Question: why can a small amount of nanoparticles be as effective as a large amount of bulk material? Because nanoparticles have a high surface area to volume ratio, allowing more interaction with other substances. Question: why must scientists be careful when using nanoparticles? Because their small size allows them to enter the body and environment easily, and their long-term effects are not fully known.